This is no ordinary workbench. It's a massive custom-built platform for two 6-axis robot arms, created for common labs in Singapore to apply AI to repetitive work and streamline real-world automation. And a huge thanks to QIDI for sending over this 3D printer, because without it, I wouldn't have been able to create all the custom parts required for the electrical components of this project. To keep things organized, this video is split into chapters for you to follow along easily. And with that, let's get started on part 1. Long before the QIDI 3D printer arrived, there was already a lot to prepare. The first task was designing a switchbox for the light switches. That initial print revealed exactly what needed improvement. Iteration by iteration, I refined the design. 4 versions later, I had a perfect switchbox, and every failed prototype was retired to the recycle bin. And then there's the switchboard, by far the most complicated piece. This alone took me a month to get right. This is where all the wires come together. For cable management, I need to design some slots for cable ties. And for the multiple connections, I'll be using these terminal blocks. I printed it in dual colors for the first time, but the color bleed was too obvious, which left me with these lines. But with so many connections needed, a complete redesign was necessary. This new version was printed using a significant amount of tree supports to maintain those overhangs. And with the support settings dialed in nicely, removing the supports became surprisingly therapeutic. So, here's the finalized prototype for our switchboard. In this design, every component has a specific job to do. For example, this WAGO plate holder, and more of this later. Next up, we need a cover for the switchboard. This is to keep all the wires completely concealed and protected. However, this design pushed the limits of what's printable. It suffered from warping and layer delamination. This was experimented with more than 10 different approaches, all without success. Thinking it was a slicer issue, I tried 2 fixes, changing the print orientation and adding a brim to pin the layers down. But neither approach made a difference. This was incredibly frustrating. It meant I had to go back to the drawing board and design a completely new cover. I redesigned the cover as 2 separate pieces to keep it printable, then fastened them together with screws. This version also features a recess for our logo plate and 2 large openings so the cover can be gripped and removed for maintenance. That brought me to my next task, concealing the wires that exit the extrusions at certain junctions. Here are the prototype covers. They not only shield the wires but also double as corner brackets. After several rounds of tweaks, this is the final iteration, and it does exactly what it needs to. Then there are the wires for the LED strips, also exiting the frame. After multiple redesigns and plenty of failed prints, we're finally nearing the end of the prototyping stage. For the power supply unit, I designed holders that mount onto the 4080 extrusion. Their job is twofold: secure the unit and shield the user from accidental contact with the electrical wires. Of course, this precise fit doesn't come easy. It took endless measurements and a whole lot of failed prototypes to get it right. And finally, the machine arrived. Thanks to QIDI for sending us this QIDI Q2 3D printer for review in this video. The moment we received it, Ben and I couldn't wait to do the unboxing. The first thing we noticed is how professional the packaging is. It's amazing how many items can be stored in this one box. This printer has a print volume of 280 by 280 millimeters, which turned out to be just right for our project today. What came with the package is this riser, designed to lift the printer's top glass lid, solving filament path, clearance, and thermal issues. And of course, just like any new printer, there's some initial components set up, which is exactly what I'm doing here. For all of the 3D printed parts required in this project, we'll definitely be printing them on this QIDI printer, so you can evaluate the machine's performance from your own point of view, right alongside mine. A lot more components came with the printer, many of them for the multi-filament box, which allows me to create prints in more than one color. Even the glass lid has a surprising feature. It can be pushed back for ventilation, helping to prevent clogs when printing with certain materials. Seriously, who even thinks of something like that? In the very near future, I'm going to design an exhaust system for this QIDI printer to vent fumes directly out the window. But for now, we'll have to print everything outdoors because I want to use ABS filament for this project. The QIDI's touchscreen is seriously impressive. After more than 100 hours of printing, I can honestly say it's the standout feature, especially when you're offline. And now, after approximately 30 minutes, we're ready to power on the machine for the very first time. This machine has automatic self-calibration right on startup, which is fantastic news because it literally sets itself up. The less we need to tweak, the better. Time to bring it outside. Over here, we'll print all the customized parts required for this project. And spoiler alert, it's going to take days to completely print all the parts. To begin, the type of filament and the colors can be specified directly from the touchscreen. And with that, let's start the printing.
Go, push it, go.
Let's begin with the WAGO clips. These are by far the best connectors I've ever used, and they snap right into the plates with that satisfying click. Given the amount of wiring ahead, we'll need 2 sets of these. And with our new 3D printer, it's time to print the actual switchboard, now in dual colors. First impression? The print turned out great. Support removal was a breeze. Even the ones inside the holes popped right off without a trace. Hole tolerances, spot on. I wanted the heat inserts to sit just like this before pressing, and they did. The holes were so perfectly dimensioned that pressing in the heat inserts was genuinely enjoyable. But with that said, I was still super cautious with the soldering iron. This thing took 12 hours to print. No way I was going to risk messing it up. The WAGO plates will be attached with super glue. For this part of the design, I didn't see the need to overcomplicate things with screws. But for the terminal blocks, the holes were already there. So I went with screws. Simple, secure, and no reason to reinvent the wheel. Every hole designed into this switchboard has a purpose. These, for example, are for cable ties. They help manage the cable mess at the 90-degree bend. Some wires will start at the terminal blocks and travel toward the other end, while others will end up in the WAGO clips. As for the names printed on the switchboard, they're extremely important. They help me identify which connection belongs to which line of LED. You might be wondering, what's the reason behind all this complexity? Well, the customer wanted 5 individual switches to control the lights. A simple request that demanded this level of detail. And to avoid compounding any errors, every single circuit is tested at each step of the way. To avoid confusion later, all exiting cables are labeled. The second terminal block is wired first and screwed into place, and every possible connection is made now. Then, before the mess gets worse, cable ties hold down the sections that are already done. All of this was necessary because, even during the design phase, I already knew we'd need to semi-assemble the switchboard and thoroughly test the circuits in advance. This kind of thing has to be done way ahead of time. And with this done, we have to move on to tackle the switchboard cover. After the entire design change, we finally managed to get it printed, totally without defects, though it did take plenty of supports to handle all the overhangs. The final cover is made up of 2 parts, designed that way for printing. Now we just need to join them. These holes are meant for inserting socket hex bolts, multiple of them, to hold the 2 parts together. Honestly, if the first design had gone according to plan, I wouldn't be here adding extra hardware. But hey, this is how problems get solved, and this is how I fixed it. Alright, after inserting all the bolts, believe it or not, the design actually worked. I figured I'd lock things in permanently, so I ran a bead of super glue along the inner seam. Instant regret the moment it's set. But hey, at least it's invisible from the outside. Then there are these 5 holes that need to be opened up for mounting screws later on. I used a step drill bit for these. And so, after hours of design and problem solving, and after days of printing on this switchboard cover, I have to proudly add our logo to it. I've earned that. Let's talk about how I made the Switchbox now. The QIDI 3D printer handled the large print easily, though we did have to print it diagonally to fit on the bed. The prototyping phase was full of changes, tweak after tweak. By the 5th print of the switchboard, I think I finally ran out of things to improve. For example, after all the prototyping and adjustments, the dimensional accuracy is exactly spot on. These boxes press in so perfectly, you couldn't rattle them out if you tried. But despite that, as snug as it is, we're still securing it with screws through every mounting hole. Because gravity is not on our side here, that the Switchbox lives upside down under the table, so everything needs to stay put. All right, nothing fancy here. These switches came straight from the hardware store. Still, before we go any further, I'm running through a dry assembly. I need to feel confident in the end result before taking the next step. Because with 5 switches managing 8 separate LED lines, trust me, there's still a lot that could go wrong. The mounting bolts and nuts should also be put on in advance, getting everything ready for the assembly stage. And to facilitate neat wiring, these slots were also designed in place for cable ties. The other side of the Switchbox has a dedicated mount. 2 wood screws will secure it directly to the underside of the panel. And speaking of the part itself, let's take a closer look at the print quality of the QIDI 3D printer. I designed this myself, and the printer delivered a very successful outcome. Okay, let's quickly put on this external mounting plate onto the side of the Switchbox. This dry assembly is almost complete, but we're not taking this to the structure until the wiring's fully sorted. My main concern is to ensure every wire is properly labeled, organized, and neatly tucked away with cable ties into their respective bundles before they exit the Switchbox. As for the QIDI printer, I've run quite a few prints through it at this point, and most of what you're seeing assembled came right off its build plate. For me, the printer is fantastic, and the people on my team love the machine, the speed, the print quality, everything. So, what do you think? You've seen what the QIDI can do. To get the printer, the link is already in the description. And for us, we'll be moving the QIDI to the workshop, where it will take on heavier tasks and responsibilities for our future projects. All these wires get organized now, cable ties sort everything out neatly, and once the Switchbox is complete, we'll be heading to the workshop for the next phase, material preparation. If the finished product is going to be done right, the preparation has to be respected. This structure needs a huge number of drilled holes, each one essential to strength and to preserving the aesthetic look of the final product. That's why we've planned internal joinery on every single perpendicular connection. For the 4 main vertical posts, we're using 50-50 aluminum profiles. Throughout the build, I'll break down why specific holes were drilled and what purpose they serve in the overall design. With pencil in hand, we mark exactly where each hole goes, nothing left to chance. These marks ensure we drill in the right spot, so internal bolts can do their job, creating blind joints that lock everything together from the inside. To help join a 40-80 profile to a 50-50, we'll use this jig, which allows us to place 2 holes exactly 40 millimeters apart. And a quick finger tighten is all it takes for now, just enough pressure to hold the jig steady while we drill. And only in a couple of minutes, 2 8mm holes placed perfectly down the middle of the extrusion, ready for a blind joint. Next, for all the corners, we'll also need 2 holes on each side, and this is the jig that helps us get it done quickly. But of course, we've done this process more times than I can count. So when I wanted to speed things up, I started using this jig for our 50/50 profiles. It lets us drill multiple pieces at once, cuts setup time way down, and keeps the workflow moving fast. I'm handling all the drilling today, while Iscons takes care of all the markings. This project requires at least 2 people to build. Later during assembly, you'll understand just how massive this structure really is, and why I can't handle it alone. There's a 12mm hole we'll need to make, where the electrical wires exit the structure. This special jig allows us to pierce only one side of the extrusion easily and right on target. And of course, whenever possible, we'll add a chamfer, just to take off those sharp edges. And to help picture where this is going, here's a look at the final result you'll see later on. We've created a few more jigs to make electrical wiring possible. After multiple projects building structures with integrated lighting, we've learned that drilling distances at 18, 28, and 38mm is the sweet spot for 40 series aluminum extrusion. By drilling this way, we've opened the door to a wide variety of wiring methods that would otherwise be impossible. With different variations of these jigs, we can create the same type of holes on different faces of the extrusion. And with all of this done way before assembly, the preparation is definitely adequate to ensure a smooth, uninterrupted build. Wood panels will be added at the very end. To secure them through the extrusions, we've placed 4mm holes all around, each one ready to accept wood screws. And just to be sure everything makes sense, the 3D model reveals exactly where each wood screw lands. Our 4080 freehand jigs will be required here. We need to place multiple precise holes all over this profile. In this case, I set up 2 jigs and drill them all at once, relying heavily on the markings Iscons prepared for me. We're running multiple jigs on this build, each with its own job. This offset jig, for example, helps us drill consistently 20mm from the edge, and that's just one of several we're using to get every hole exactly right. But there's one last specific jig I want to mention, one made specifically for this project. We need to install the switchboard at this specific location later on. It's designed to be screwed onto the face of the extrusion, with very specific screw hole locations to match. So instead of manually figuring out where to drill, we made this jig, built specifically for these 4 holes. It wasn't printed very well, but let's move on. But of course, these are just holes. In order to accept M6 screws later on, we need to tap threads into them. Using my favorite tapping bit and a bit of tapping fluid, M6 threads are created within these holes, followed by a light chamfer to take off the sharp edges. And for all the tools and jigs you've seen in this video, you can find them on our website, thealuminumcarpenter.com. After completing all the drilling, we position the extrusion vertically along the wall. The markings were left untouched at this stage, as they are still needed for reference during assembly. The key joinery decisions were all made during the 3D modeling phase. Now, as we move through assembly, we'll show you exactly how we achieve strong, clean joints that don't compromise on looks. In this section, standard end fasteners are the way to go. They maximize contact surface area for the strongest possible joint. And of course, we've already marked the alignment lines on the extrusions, so everything is ready to go. Now, with our flush plates guiding the way, each part comes together perfectly, securely fastened, perfectly aligned, and completely flush. Every internal joint gets a dose of Loctite, because with robots in motion, vibrations are inevitable, and we want every connection to stay rock solid for the long haul. This structure will be assembled in sections before final installation. To make things more challenging, we can't fully assemble it in our own workshop. It's too large for our lift. That means the final assembly will have to be completed on-site at the customer's office. Which also means every single joint we can finish in this workshop has to be absolutely perfect. And that's exactly what you're seeing here. To maximize strength on certain joints, we paired external brackets with the internal joinery already in place. Spring leaf T-nuts work exceptionally well with 40 series aluminum extrusion, and in this video I've slowed down the process so you can clearly see how it's done. Now, let's move on to the main section of the table. We're kicking things off at the back, working with the extrusion that holds the most drilled holes. For safety reasons, we're clamping everything securely to the assembly table. With a workpiece this big, it's the only way to stay in control. We're reinforcing several joints using 40-80 brackets. In this case, T-bolts and flange nuts offer the most convenient fastening solution, and everything is tightened down while a flush plate remains in place to ensure alignment. The next parts need to go on now. This time we're using washers instead of standard end fasteners to increase the grip surface area. You're probably wondering, why not just use standard end fasteners? Well, they're excellent, but they take up internal space. And over here, I need that room for wiring and slot covers, which would otherwise collide with the standard end fasteners. Okay, I made my point. Let's speed things up. At this stage, the top section is fully assembled, and all flush plates used for alignment can now be removed. We go through a lot of flush plates on every project, and that's intentional. At any given moment, they're holding joints in position, keeping everything true until the very end. It's one of those tools you just can't afford to overlook. Now we'll move the top section out of the way and dive into the bottom assembly, where several different methods are worth taking a closer look at. With measurement lines drawn for the next set of components, we followed the same process, aligning, tightening, and reinforcing. We tapped the extrusions gently into place and flushed them to perfection. Because we promised the customer an exceptionally strong table, extra brackets were added for additional reinforcement. Once everything was solid, the flush plates were removed. And yes, we always have to keep them on till the end. Now, we're faced with a joint that requires a bit of creativity to secure. To pull this off, we'll need two long Allen keys, already inserted into the hex bolts, positioned to meet the 40-80 extrusion at the same time. This allows us to turn both screws simultaneously, reducing the gap to nearly zero. The joint isn't tightened just yet. We still need to flip it over to complete the alignment. With the joint still loose, we bring in the 40-40 perpendicular alignment jig, sliding over both extrusions to get them perfectly aligned. And once that's done, a flush plate on the back locks in the alignment, and the extrusions are ready to be tightened permanently. And this, using dedicated tools for this specific task, is how we achieve joints that are perfectly flush on all sides with absolutely no guesswork involved. Now that you've seen how it's done, it's time to pick up the pace again. One extrusion after another, we build with rhythm and seamless teamwork, each fastener locked in with exacting precision. Everything seems all right so far, and the momentum's strong. But just like in so many of my projects, I made a huge mistake, again. Here's the thing. Sometimes, fasteners have to be pre-installed before assembly. And right about now, we've passed that point. So what does that mean? It means we're taking a whole lot of this apart. That mistake cost us at least an hour, an entire hour, just to go back and insert one simple piece. And to put everything back together again. Seriously, if anyone has a way to keep this from happening, tell me. My ears are wide open. Approximately an hour of repairs later, we finally revisit the point where we had to stop, all because of this one fastener. Now that normal service has resumed, we'll use the same method, just in a different orientation, to complete this next joint. Every corner, every connection, every joinery decision, it all has to be carefully thought through during the design phase. Some of our designs take weeks to finalize, simply to guarantee completeness before we even buy the materials. And if you also want to try this project, it's already listed on our website. With this corner nicely done, we're now ready to merge the two separate structures together. With projects as complex as this, we often have to carefully plan the assembly sequence. For safety reasons, the manageable weight of each individual section has to be taken into consideration. And when merging components together, we have to find a way to keep things simple, to prevent a whole lot of frustration when things don't go as planned. In our case here, there are only 4 bolts to balance within the extrusion, all of which will meet the bottom section at the same time. Right now, the structure's still light enough for me to flip by myself, which means I can take care of the remaining alignment and tightening without needing an extra pair of hands. And honestly, none of this would have been as smooth without my MFT centerpiece assembly table. Rock solid, reliable. It's the backbone of this workshop. I built it a while back and it's given me the kind of solid foundation that, well, you just can't buy off the shelf. At this stage, we can move on to the 4 vertical legs. This is a dry run, assembling everything here in the workshop before breaking it down again for transport. For the legs, we're using 50/50 extrusions, not the 40 series we've been using throughout the rest of the frame. That means standard alignment methods won't work. So to get everything perfectly centered, we rely on our custom alignment jigs before locking anything in place. And as we continue bringing more parts together, the remaining methods for inserting each piece become more and more limited, which is exactly where we need to get creative, think outside the box, and find clever ways forward. And by now, you're finally getting a sense of just how big this thing really is. And yeah, now you see why it won't make it through the door, let alone the lift or the van. That said, we're still pushing to get as much done here as we can. Why? Because hauling all our tools to the customer's office for a full build is just not practical. Which is exactly why projects of this scale come with a higher price tag. And that price reflects more than just materials. It's not just about the build, it's about navigating the extra logistics, the limited workspace, the tool hauling, and all the inconveniences that come with it. It all adds up. And honestly, it has to. And then there's the slot covers, one of the more tedious jobs. That's why we make sure to get them done while we're still in the workshop. Trust me, you don't want to be doing too much of that in someone's office. We're just about done with the top section. It came together as 2 separate parts and we'll only secure them at the very end, using external brackets for a clean and solid connection. We also promised the customer that every exposed bolt would be stainless steel. It's not just about strength, it's about keeping things looking clean and corrosion-free for years to come. And if you want to know how heavy it is, here's your answer. Okay, our dry assembly is complete. The next step, take it all apart, because this thing is not going anywhere in one piece.
What about what the girls want? What about self-destiny? Shouldn't even be an argument. Consider what's best for me. What about what the girls want? What about self-destiny? Shouldn't even be an argument. Consider what's best for me. What's best for me?
All right, we're finally on site. This is the customer's office, and we've got about 4 days of work ahead to bring this project across the finish line. Using the holes we drilled earlier, we're now going to run power and install the lights the customer ordered. Running cables inside the slots means navigating around internal fasteners and passing through a series of drilled holes. That's why the path isn't a straight line. And throughout the rest of the assembly, slot covers will go on, concealing every single cable from view. You might not realize it, but the wiring paths were the most time-consuming part of this entire design. A whole month went into modeling every component just so we could figure out exactly where to drill, before we even touched a single extrusion. But before we get there, let's put on some wheels first. For this project, we've got 2 kinds of heavy-duty casters. One type mounts with a plate, the other secures using a threaded rod. But before we can do that, we'll need to prop up the heavy frame first, using some makeshift stools. Earlier, we cling-wrapped the edges to protect the office flooring. Now, the thread reducers we inserted previously have to make way for the M12 threaded rods. But even with the casters on, we're taking an extra step. A layer of cling wrap around each one keeps them from slipping or rolling while we tilt the structure up into place. And all that wrapping, just to take it off again for one single task. Right after that, we can finally roll the frame around. We're ready to keep going, but the customers just need a few minutes to talk things over. And while that's happening, let's take a quick look at the 3D model, just to see how far we've come and what's next. To really understand what's happening inside the extrusions, we have to hide several layers of the model. You can really see it now, a whole web of wiring running through the frame, and it's clear just how much planning went into this. A complete network of wires tucked away inside the extrusions, all to power the lights, completely out of sight. Here's everything we need for this part of the build. And instead of bringing out the soldering iron, we're using these clip connectors to keep things clean and efficient. The pins don't really meet. Therefore, I needed to bend the pins slightly to ensure a firm connection. And once we snap the clip shut, we can test it with power. To show you some key parts of the wiring, I've mounted a GoPro on my forehead, so you can see exactly what goes on from my point of view. These heat shrink connectors work really well. They fit through the drilled holes and sit easily within the slots. Using my dedicated roller, the entire strip is pressed deep into the extrusion, removing the tape adhesion as we go along. And up above, I always tuck in a little extra wire. A bit of slack now means a lot less headache later if something needs servicing. With every few connections, we pause and test. It keeps things simple. Catch any issues early and never wonder where things went wrong. And now that you've got the idea, let's pick up the pace and head closer to the next key section.
What about what the girls want? What about self-destiny? Shouldn't even be an argument. Consider what's best for me. What about what the girls want? What about self-destiny? Shouldn't even be an argument. Consider what's best for me. What's best for me?
What you just watched was how extensively the electrical paths were planned and executed. This is where we mount our 3D printed switchbox, the one that will eventually sit below the tabletop. I'll check again for flush, then direct the wires toward the back of the structure. And a couple short pieces of slot cover will hold them in place for now. A few wires naturally exit the frame at this intersection, but this 3D printed piece hides them completely. And once we confirm there are no more wires going in, we seal it up with slot covers. And wherever the LEDs run, we're using translucent slot covers. They diffuse the light beautifully, spreading it evenly across the surface and giving the whole area a soft, functional glow. For this project, every slot gets covered. No exceptions, unless we've specifically left one open. Once a slot has wires in it, it is off limits for anything else, and that's exactly why we spend so much time planning up front, to get it right on the first time. Next up, moving the power supply into position. We'll mount it using these custom 3D printed PSU holders, designed specifically to fit onto 4080 extrusion. Within this design, we also need to ensure the entire frame is electronically grounded for safety. To make sure the ground has a solid conductivity, we scrape away the paintwork, right down to the raw aluminum. That's where the ground wire gets attached. We then use a multimeter to check for continuity on all exposed metal surfaces, ensuring there's a complete and reliable path to ground. From here, the wires are cut to length, crimped, carefully secured between the two washers, and pressed into the extrusion using a short piece of slot cover. By doing it this way, most of the grounding hardware stays hidden, right alongside the power supply. And now, we've reached the most detailed stage of the entire project. The power is disconnected, and for now, we will work in the dark. One by one, the mains wires are torqued down into the PSU terminals. Then the covers are set in place, just enough to keep everything secure for now. The switchboard, already partially wired, now has to be set in place to complete all the electrical circuits. This part alone took me 3 hours to put together. To make sure it stays rock solid for good, I've added several mounting screws. This is one component that absolutely cannot move. It also has to sit perfectly flush with the top of the extrusions, so that the pre-drilled holes align exactly with what comes next. With just 2 flush plates, we ease everything into perfect alignment. Then we secure every screw, especially those matching the custom drilled holes, while being extremely careful to avoid pinching any wires. From the switchbox to the switchboard, every connection now has to be made, one by one. Each wire finds its place in the WAGO clips, completing the circuit. Completed wires are then closed up with slot covers, and cable ties hold the loose wires neatly, routing them directly to the PSU. And yes, every wire was labeled well in advance. Without that, trying to sort through all these red and black connections on the first go would be nearly impossible. And with the switchboard semi-assembled beforehand, it's clear we anticipated this complexity as early as possible. The ends of all these remaining wires go through the 3D printed cover and directly into the PSU, and with that, the setup gets closed up for good. Of course, we couldn't just stop there. All those remaining wires had to be connected one by one. That alone took another full hour of focused work, carefully landing each wire into its terminal. At this point, there's only one thing on my mind: testing. I have to know if every connection actually works, and before that, I'm mounting a multi-plug socket right here, just like the customer asked. You see those 3 wires coming out of the frame? They need to be insulated and terminated with a plug, and that's happening now. And once that's done, with the plug in place, here it is, the moment we've been waiting for.
'Cause I just can't stay here.
Well, that worked perfectly, which means I can put most of my tools away and finally install the switchboard cover. And with that final cover on, today's marathon is over. The electrical system is fully finished, a task so involved it carried me all the way into the night. But of course, you know me, I still feel like I can accomplish more. The perfect way to cap off such a productive night. And make no mistake, this is a complex build, but with enough determination, it's absolutely achievable. For those of you inspired to take it on yourself, you can download the design on our website. There are only 2 pieces of wood panels in this project, but don't let that fool you. It's not going to be that simple. Because before the panels can even go in, they need a series of precision cutouts. Normally, we'd let the CNC handle this, but these panels are just too big for our machine, so it's back to the old school approach. And yeah, after that cut, I feel like throwing this jigsaw away. But we're not done yet. The router will clean it up and make it right. But first, we need to score a line along the exit path to prevent tear out. But in the end, this little makeshift router jig, it totally saved the day. To avoid another round with the jigsaw, I brought out the Japanese handsaw. Slower maybe, but way more in control. And we need another jig to guide the flush trim bit exactly where I want it to shave. And of course, this was repeated on all the corners, achieving a similar result, just like this. Next, we need to add a couple of desk grommets to the top surface. After extensive measurements, we located where to place the pilot holes, then used a 50mm hole saw to carve out both openings. Perfectly done. We'll also need to precisely locate the mounting holes for the robot arms, getting them ready for installation. Everything we're doing now has to be extremely precise. All these holes have to line up, not just with the holes drilled into the extrusions, but also with the holes on the robot's mounting plates. Every measurement was checked, every task completed. Still, there's that moment of uncertainty, a leap of faith that when we assemble, it all comes together. We prepared the wood entirely based on theory. Before the wood panels go on, everything gets a serious turpentine wipe down. It clears away every pencil mark and even helps buff out some of the lighter scratches. We need to do this outside because of the strong smell coming from the turpentine. And after that, the structure has to be navigated through the tight walkway and eventually flipped onto its back. More slot covers are applied, and the whole frame gets a layer of wax, bringing out that sleek black shine across every surface. The bottom panel goes on first. But here's the thing, we've never actually test-fitted it. Every hole, every alignment, every assumption, it's all been based on faith in the numbers on a screen. If this doesn't fit, we're looking at lost time and extra cost, two things nobody wants. But of course, we got it right, and right there, that's what a perfect fit looks like. We're using wood screws, long enough to go through the drilled holes in the aluminum extrusion and reach the wood panel. Multiple screws are required to permanently secure it in place for good, and the top panel will get the exact same treatment.
Can't stay here. Stagnant under pressure. Let me guide you. 'Cause there ain't no way. Feel like taking over. 'Cause there ain't no way. No way.
And finally, that was the last wood screw. A few more things before we call it a day. The mounting bolts and accessories for the robots, all laid out and ready to go. The light switches are checked one last time, operating smoothly, just as promised. And not forgetting the grommet lids for the customer. When it came time to mount the robot arms, it felt like the whole team was there, and frankly, it made the moment feel pretty special. The robots and their hardware definitely have some heft to them. That said, I'm not concerned, because this table was designed to handle the weight with ease. And putting in all the long bolts, all the way through the tabletop and the aluminum frame, took quite some time. But of course, this step has to be done well before use. For us, watching them do their robot assembly has been incredibly satisfying, knowing that we made their table possible, from an idea to reality. Well, you must be wondering how long did it take us? 3 months. That's how long this journey lasted, from early conversations to final assembly. And honestly, we do it all over again in a heartbeat. Now, over to the folks at Common Labs to tell you more about their vision.
Hey everyone, my name is Lawrence. I'm here with Sambit here at Common Labs. We're a startup here in Singapore. Today, I just wanted to introduce this brand spanking new workbench, custom made for us. As you can see, we've got two 6-axis robotic arms installed. The idea is that we would have a platform that we can sell to our customers. They can install their own arms. Any brand that they choose, they can have one of these tables built or bring their own table. And I'll let Sambit talk about the platform itself.
Yeah, so it's still work in progress. Some of the cameras have been installed. There's still a place for installing more cameras and hooking them up. The idea is that if a human performs a task such as assembling some electronics component or a battery pack or doing an inspection of some lenses or some other precision work, we can use our computer vision system and these cameras to capture the task that's performed by the human. And then we can digitize the task. And in the end, our platform can use the digitized version of the task to control the robot and copy the same task. So that essentially a task once demonstrated by the human can be repeated multiple times by the robots without requiring any programming. As we mentioned, it's still work in progress, but we have some very small demo of how the arms move around. Nothing fancy, it's just a 3D printed block that's being brought in front of the inspection camera, so that the second robotic arm can take a closer look via its built-in eye-in-hand camera. And on this screen over here, you can see the 3D view of what the eye-in-hand camera sees. And essentially, we can program the robot to look around, take a closer look at the task at hand, and capture its full 3D shape in order to figure out how to grasp and manipulate the object properly.
Yeah, so that's what we're working on. And as you can see, we're still early, but we're looking forward to introducing this solution to the market very shortly. I personally wanted to thank the folks at the Aluminum Carpenter for helping us build this fantastic table, and we look forward to sharing this with the market very soon.